Welcome back from last year. We had this talk last time. I don't know many times you've had it before, but this is one of the many. So get ready for this year's edition. This time it's Florian, me, and Carlos and Michelle who's presenting. And as we usually do, we start with the compositor side, and then we move slowly up the stack to the shell side. So let's just start. Mutter, our compositor library. I think this is the biggest change that we have. No more X11 backend. It's mostly red lines in GitLab. In the Git diff is a lot of stuff that got removed. No more GLX, which is the rendering infrastructure and everything that related to X11. And there were, not only that, there was a lot of complicated input device grab semantics related to clicking on a window was complicated, grabbing keyboards to do keyboard shortcuts were complicated, and everything was complicated. But now we can just remove that, and it's paved the way for so many cleanups and simplifications to everything like that. X11 scene graph related limitations we could just start to ignore. Eventually we'll be able to clean up even more. And another thing that we did, which was also somewhat of a milestone, that kind of good timing with X11 backend removal, as we enabled two long-lasting experimental features that seemed stable enough now. Fractional scaling and X-weight unscaling. So you could practically get high DPI X11 applications by default, and fractional scaling, and everything just works perfectly. There is this X11 style layout still possible, but that's something that in the future we can be able to clean up as well. It's there now for if it's actually needed for something, which we will find out in the coming cycles. But that is giving even more opportunity for creating a linear architecture. There was a bunch of improvements to like the APIs talking to the other components of the stack, screen sharing, remote desktop, and portals. Better performance in general. Michelle did a bunch of performance improvements to have better handling damage tracking, to just make for example, the remote desktop server copy much less data over the internet by knowing what changed on screen, which was pretty great. HDR for screen sharing, so you can get HDR with screen sharing. And Carlos, to some project that actually uses it now, it's light, sunshine or something. Sunshine is actually using it already for streaming HDR content from the screen sharing HDR content. And some plumbing for the portal backends was added. For example, clipboard for input capture. The input capture when you can, desk flow, where you move the mouse and it goes to another computer, and you also want to be able to integrate the clipboard. So the plumbing for that was added this last year. There was also some changes in window management. It was somewhat driven of the needs of the kiosk. I don't know how many know about the kiosk mode or kiosk compositor, GNOME kiosk. It has certain needs. It needs to be in control of the windows and how they are positioned, everything, and lots of window management features was driven by the needs of kiosk, but I think many of them will actually be usable for Excel extensions and any kind of general improvements to the window management that we have. One of these things are external window management rules, which simply lets GNOME kiosk and potentially an extension just to override any kind of rules that the Mutter itself, the window management rules there, implement. Bilal is working a lot on cleaning up the Kogel, the abstraction over the graphics pipeline rendering architecture, removing a lot of unused things and clean up redundant functionality. We don't need multiple ways to do shaders, for example. We can have one way and then get rid of the other ones. We can concentrate all the EGL and OpenGL stuff into their corresponding actual backend objects, which could potentially make it easier at other rendering APIs. And now I'm going to change to Misha.
Thanks, Jonas. I'd first like to talk a little bit about what's been happening related to color management in Mutter. The first thing is that in Mutter 50, there is now support for handling white color gamut displays correctly, even when HDR is not enabled. And I stressed the latter part because HDR kind of implicitly covers white color gamut as well, but with HDR disabled, previously Mutter always assumed that the display expects data in the sRGB color space and produce the output frames accordingly. But for example, if you have a laptop with a white color gamut panel, then that is probably not the case. It probably expects the data to be in its native color gamut. And so we have a new third mode now, which is also still SDR. It's not HDR, but it uses the color gamut information which is stored in the edit data, which is provided by the display, and just produces the output frames for that color space. And so far it seems to be working pretty well. So at the moment it's only available via the GDCTL command line utility. It's not exposed yet in the control center display settings, but I hope that will come at some point as well. The next thing is the Wayland color management protocol, where Mutter support for it was bumped to the version 2 revision. This is mostly minor changes, which probably won't be noticeable for most users. So I only put one specific thing on the slide, which is that Mutter now uses the gamma 2.2 transfer function with SDR instead of the sRGB piecewise transfer function that it was using before. That might be noticeable in some cases, in particular with content which has a lot of dark areas, like maybe some dungeon game or something like that. And finally, Sebastian just got the ball rolling recently for revamping the color pipeline that Mutter uses for producing its output frames. This will open up possibilities for lots of things that haven't been possible so far. Just to name a few examples, it will allow Nightlight to work correctly also with HDR enabled, and it will allow adjusting the white point for each display separately. And it also will allow Mutter to offload some of the processing to special hardware support via the KMS API, which should be more efficient than using the GPU shaders for everything. The next thing I want to talk about is variable refresh rate, also known, or I guess commonly known as VRR. This is also the third feature in Mutter 50, which was previously an experimental feature, but now it isn't anymore. So some of the rough edges that were there before were ironed out for the 50 release. And on top of that, there were some further improvements. For example, the VRR support in Mutter now also works well when the Awalum client uses the commit timing protocol, which basically allows controlling the timing of when a frame is presented on the display. This is useful, for example, for frame rate limiters. Even when using VRR, it can be useful to prevent the frame rate from going above the maximum refresh rate, because then you will avoid some bad effects when the refresh rate kind of varies around the maximum. So this is useful for that. And also, while VRR is active for a full screen surface, if the frame rate of that surface becomes low, like maybe 30 frames per second or even lower, previously the mouse cursor would also move at a very low refresh rate, and it would be kind of awkward. But now the mouse pointer can move independently from the full screen surface refresh rate, and it can go up to the maximum refresh rate according to VRR. And the last thing I'm going to talk about is performance. There have been various improvements for hybrid graphic systems. The most common example of that is probably laptops with an integrated GPU and a separate discrete GPU, which is usually an NVIDIA one at this point. And so there have been various improvements to make transferring the contents between the two GPUs more efficient, to give better performance in that scenario. There have also been workarounds for various driver issues in the NVIDIA driver. Unfortunately, it doesn't always stick very closely to the defined semantics of the APIs that we are using, but we found a way, or we found ways to handle those issues, which are, I'm not sure how to put it. I guess it could be worse. And frame scheduling. Those who know me well know that this is a topic that's dear to my heart. So I'm going to try to provide also a little background why this is important. You might wonder, why does Mutter even need to schedule frames in the future? Why can't it just start working on the next frame as soon as possible? And the answer to that in a nutshell is that there is a trade-off between smoothness on the one hand, which requires hitting every refresh cycle of the display, and on the other hand, there is latency, which corresponds to responsiveness from the user point of view. And so if we were to always start working on the next frame immediately, we would have the resulting smoothness would be as good as possible, but the cost for it would be that the system would feel relatively sluggish to respond to the user input. And on the other hand, the flip side of that is that if we wait too long before we start working on a frame, then we might miss the next display refresh cycle, which is also not, isn't smooth either. So we have to find some kind of balance between those extremes. And we are trying to dynamically find a balance which works for the given system, because the balance also depends on the performance characteristics of the system. But it's tricky, and so we are always trying to improve that. But so previously we were basically, I guess, mostly pushing harder for low latency, for better responsiveness. But lately we've got a few complaints by users about the smoothness not being as good as expected. So now maybe we're trying to find ways to improve the smoothness without sacrificing too much responsiveness. Finally, there is now a work in progress merge request for properly supporting so-called tiled monitors, which involve multiple logical display connections between the GPU and the monitor. And pardon? Yeah, it's a less. Yeah. Okay.
Das ist zu leise, sollst näher ans Mikro gehen.
Okay. I hope you can hear me now. Sorry about that. The main benefit of this will be that there will no longer be a tearing line in the middle of the display, because currently Mutter is updating both halves of both tiles of the display independently. So it can happen that one of them is updated for a new frame, but the other one isn't yet, and that results in a tearing line. So that will be fixed, and also because both halves will be handled in one go, combined as a whole frame, it will be more efficient as well.
Thanks, Michelle. So yeah, there's also been some work on getting Mutter to be a lighter compositor, have lighter dependencies and have less legacy dependencies. First one, it was, it's not complete yet, but we are pretty close to having no kernel dependency on Mutter at all, which is nice. And then we've also been, there's been some protocol updates and some Wayland improvements that in order to support more things or doing and catching up with Wayland development and whatnot. So the first thing is WL fixes, which is a relatively minor protocol with some fixes actually for the core protocol. It became hard to fix it in the core protocol, so it spun a separate protocol for it, and we implemented. What was it about? It was destroying globals, or?
Not constraints, but
Right. Well, anywho. So pointer warp is another protocol which is, I'm personally not really fond of it. Like it's taking a bad pattern from X11, but it's already here, it's already done, so we support it as well. This protocol does allow you to move the the pointer to a different place and in order to do anything with it. And yeah, we used to have a constraints and locking, which was used to implement, for example, supporting games where you hide the pointer and you move the character or whatever, but the pointer that is underneath actually locked in place, and it doesn't move, but it still transfers the motion events to the client. But that was not enough for some use cases, so now we support this. There's also the X background effect protocol, which does allow us to set some background effects, like blurring the background of windows and having things underneath be shown within blurry as well and whatnot. So we now support this protocol. There should be some exciting things that can be done with it in terms of UI and everything. And there was also the color management protocol version 2, which Michelle already covered excellently. So I'll just go through it. And the text input protocol, which is, even though it was, a minor number update, it had fixes for quite big shortcomings for a few things in terms of internationalization and on-screen keyboard support. And now the protocol is already in place and we implement it, and it has fixed quite a few things that were a little bit of a pain in terms of internationalization. There's been also some input improvements, like now that, I'm starting from the beginning. So we now use more gestures and controllers, replacing event handlers and signal connections to actor signals in GNOME Shell, and it's been replaced with gesture objects and controller objects, which are self-contained objects that are able to handle tiny pieces of input. And it's an improvement in terms of having more control points to handle input properly and give less opportunities for screw-ups and whatnot. So we now mostly are using these objects to handle input in GNOME Shell. There's been also some work on the fundamentals, we used to have this, inspired by X11, these two tiers of devices. Like you would have the hardware devices that are the actual things in your computer that you interact with, and there would be virtual devices. These are not virtual like remote desktop nor anything. They are simply not physical devices. And those used to be represented by the pointer on screen or the keyboard focus, the caret, or things like that. So we now have a sprite object that replaces this on-screen pointer thing or keyboard focus thing, and replaces it with a dedicated object that is not the same type as the physical devices, which has also allowed us to move a lot of logic about picking, about transmitting event propagation, things like that. It's allowed us to give it a place instead of scattered all over the code. And this has been quite nice improvement in terms of getting rid of X11 isms and use something better than that. And as I said, the plan would be achieving the full removal of event handlers in Clutter Actor. It's got a plethora of signals that and the methods that you can connect to in order to handle button presses and motion and whatnot. So the idea is to finally replace everything with gestures and controllers, and then get rid of this way of handling input and rely entirely on these objects. And the end game for that is actually being able to move all the Wayland event handling into Clutter. Like right now, there is a big fork in the road. The events are, let's say, generated by the input thread. They are injected into the main thread, and then they either are handled for Wayland purposes, like sending it to a client or whatever, or they are handled by Clutter and for example, clicking on the menu on the panel or the calendar or whatever, and that would be handled by Clutter itself. So the idea is to make all Wayland event handling, removing this big fork in the road, and making all event handling be done by Clutter and be done like forwarding events and propagating events across the actor tree, and having it done naturally within the Clutter event handling code, and remove this kind of hack. This will also allow like applying, for example, effects on windows or whatever, or rotations and anything, and having input happen in the place where it's supposed to happen, because Clutter is prepared for this, but the Wayland code that we have only caters for rectangular surfaces. So it's a small improvement that we get for free with this. There's been also some improvements in terms of accessibility. And we implemented a DBus interface, which is private for screen readers, so they can query for the pointer position. This used to work before based on global coordinates, which was a no-go for Wayland. So this DBus interface works over surface local coordinates and surfaces. So the screen reader, it can know which subtree to traverse in order to find out those surface local coordinates and tell you what is underneath the pointer. And this is obviously important for people with sight issues. And there's also plans for improving the support for touchscreens for blind people and whatnot. So this is kind of works differently. Like the touchscreen is usually an interaction area, but it does not relate to the thing that is underneath. You are not tapping on something, you are interacting with the touchscreen as something else, as a touchpad, for example. So it's got some challenges over there, and but it is now something that we can talk about supporting, basically. And then there's been some DevKit improvements. And if you don't know DevKit, it is our new way to run Mutter in a nested inside a window, so you don't have to run it on your system or anything, and it's kind of convenient for for development, at least, yeah, it solves, makes it easy to work on most of the issues, at least. And effectively, the dev-kit window is now resizable, which means that, yeah, you don't have a fixed resolution for the nested matter, and you can resize the window, and the compositor running within it will update itself and to the new size and deal with it as a monitor size change. What did you mean with this?
Either via settings or just...
Oh, yeah. So yeah, you can do both, either via settings or just resizing the window. There's now also high DPI support for DevKit, which is nice and nice to have because more and more screens are high DPI, so it's a nice thing. And there's also clipboard integration, so you can copy in your host and paste into the nested session, and it will work. And there's also changes to how we map the keyboard layout. So now, yeah, we can make it work so the keyboard layout that you use on the host on your own computer does forward to the nested session, basically. So you don't have to change the keyboard layout in both places in order to test something, or you miss and you're typing something else. There's been also, we have also had, well, Jonas, I'm only helping. There's been a Summer of Code student working on GPU robustness and being able to handle GPU crashes and recover elegantly from that. So there's been quite some nice progress over there. Work is done by Like, our student, and he's been doing some wonderful work. This is a Summer Code project this year, and if you missed his talk, his lightning talk, you should go check it because it's pretty interesting. And now for the shell bits.
So, hello, and with that we are coming to the upper layer, which is GNOME Shell, which rather than Mutter, which provides the lower platform bits, to the shell, which provides the actual user visible UI. As with Mutter, I first start with a quick retrospective, what is happened over the last year. The first noteworthy feature was improved brightness controls. The most important change in that were that if there are multiple monitors that can have adjustable brightnesses, every one of them gets now a separate brightness slider, so you can adjust the brightness for more than one device rather than before where just one monitor was picked as the display brightness monitor, and the other ones you could maybe control via hardware, but not from the actual UI. This is kind of an implementation detail that doesn't round trip to GNOME settings team anymore, but uses Mutter exposes the API we need to implement this directly in GNOME Shell. So this is how it is implemented. It shouldn't make a huge difference offhand, except that it makes it easier to make further improvements. For instance, better handling of screen brightness when HDR is enabled, which has its its separate brightness setting, which doesn't map directly to the underlying brightness of the hardware. Brightness is now like saved and restored, not only when you leave or like log in or log out of the session, but also when changing between SDR and HDR modes. And let's put it like that, the brightness slider now reflects better the intention of the user rather than like the state of the hardware or the kernel. But yeah, like the HDR brightness is now like reflects the actual HDR brightness and not the HDR brightness plus the underlying brightness of the monitor, which you can only change when you disable HDR and re-enable it. So yeah, it should just make more sense now to users without going into too much details. The other feature were parental controls, which is largely based on like earlier work done by Philip for digital well-being. But the main difference is that screen limits are not like recommended, like, oh, wouldn't you like to take a break? Maybe take a walk, get up a bit, but like the screen is locked, and unless there's a parent around that will unlock it for, well, the child usually, that's it for the day, and like the device has to be like kept quiet like for the rest of the day. Well, as I mentioned, this was like done as part of the funding for digital well-being, and in this particular case by Ignazi, who unfortunately isn't here, but I've seen him in some former slides. So apparently he's still like active in GNOME and active in some teams. Some bits that probably aren't headline features, but are nonetheless worth mentioning. Offline updates, like when you log out or shut down the computer and updates are available, we offer to install them. That used to be implemented directly through PackageKit. Now it's done by a private GNOME software API. It should only make a difference for users who aren't using systems that like. It makes a difference for systems that aren't managed by packages with PackageKit, but where GNOME software does have a plugin for updates, because those are now supported. Before, those updates were just not handled from the shell. There were like quite a few accessibility improvements, not the kind that were done in Mutter, where like new features were implemented that enabled like new kinds of users to like use the system, but rather like the more tedious work of like identifying issues, missing labels, duplicated labels, descriptions that cannot be focused with the keyboard, but are kind of important to like, get the context, so they have to be exposed by some other means. So yeah, like unglamorous work, but still very important. A very tiny change, but like a very popular request. GNOME Shell has a built-in screen recorder that can be started with a key binding. The same key binding can now be used to also stop the recording, which was like a big pain point for many people. And with that, like a quick outlook for like upcoming changes in GNOME 51. We have like major work done on the login screen side. First, most users will notice like there is like a refinement of the authentication UI, like some elements move into the entry. It all looks like more balanced, more centered. There are indications whether you have to use a password or can also use maybe a fingerprint reader. When before it was more or less implied, or there were like notification-like messages shown, and it's now just like a lot nicer and more streamlined, well, as I mentioned. There were also like changes when a user is logged in locally and then tries to also log in remotely. We like cannot handle like both concurrently, so either the remote session cannot go ahead or the local session has to be terminated first. And to allow the user to pick that, there is like a choice to be made, and like the UI for that was improved this cycle. This is a bit that is not pending anymore. This is already actually in the alpha release. So, and importantly, like more support for like different authentication methods. Like apart from password, like the classical password, fingerprints, smart cards, there is also support for passkeys or web login. For details, John had like a dedicated talk about this yesterday, so you can check it out on YouTube when it's, I don't know when it's available, but it will be available. Oh yeah, and you don't have to like decide before starting the authentication with method you will use. You can start the authentication process and then make your choice. Like you select your user and then you can choose, oh, I want to identify by passkey, by smart card, or just enter my password. Again, some like smallish changes that can still be like probably worth mentioning. There is some initial support for the reduced motion setting. It would be like a bigger item if there was like more support. It turns out that like the main animations we have in GNOME Shell are really, really hard to change. Like the usual guidance is, oh, instead of an animation, use a crossfade. But that doesn't work for things like the overview, where we aren't changing between different components, but we have like different, like 3 or 4 different states, and we don't have anything to crossfade between. We just have like, oh, it's now in this state, it's now in this state, it's now in this state. So we will need some design guidance for this to like improve this support in the future. SVG cursors, this is like a very recent change, but there is now support for basically SVGs with some metadata attached that allows us to like show cursors that aren't based on X cursors, which is like very much a legacy format from the X11 world, but that we were still using on Wayland. Now we have like a modern cursor format that is probably a lot easier for the design team to update, and just generally nicer and better integrated than, yeah. Another change that, well, this one hasn't landed yet, but I expect it to land. This is a fairly small change. Usually extensions are either disabled explicitly when the user turns them off or when the screen is locked. But until now, when you shut down the computer or log out, the extension, well, just dies together with the rest of the shell process. We will now like disable extensions before that. So if an extension has to do some cleanup work or maybe save like runtime state to more like to a persistent location, then it has like a point where it can do this because it will be disabled at this point and can like, well, do proper cleanup before the system like exits. And that's it. Thank you.
Thank you so much. Do we have any questions? No questions? I don't think we have anything on the chat either. Okay then, thank you so much. It was a wonderful presentation.